All right, hey everyone. So my name is Max, and I'm the mentor for Aiden and Keith.
And last year, I was part of the Junior FLL Team Dragon Builder.
你刚刚讲课，
And now Keely will introduce herself. Keely?
Hi, I am Keely, and last year I was with my teammate Aiden with Dragon Builders.
Okay. Good evening, everyone. My name is Aiden, and this is my teammate Keely. Today, we will introduce you to Matatalab Pro Set. So, what is Matatalab Pro Set? Matatalab Pro Set is a fun way to let young programmers develop some programming and engineering skills. The three functions that Matatalab can do are drawing, music, and nature map. In order to do those three functions, you'll need a control board, small robot, manuals, and tiles. If you do not have the physical set, you can click on the link to go to a Scratch-based online Matatalab game. Okay. Can you, Melody?
Yeah, I've spotlighted you, so can Max stop screen sharing?
Yeah.
Okay, good. As you can see, here is the control board. The control board has a small tower on it so it can send the code that you coded by camera. The camera will first sense the code, then send it to the robot. Today, we're only going to talk about drawing and music. First, we'll talk about music. What tiles do we need to code music?
We will need the auto clef tiles. There is one note in the middle. There is also a white circle that you can spin to see different numbers appear in the small window.
What do those different numbers mean?
The different numbers mean different sounds. The smaller the sound, the smaller the number, the lower the sound. The greater the number, the higher the sound. It is also the same for the treble clef tiles. They have two notes in the middle, and the sound is half amount of time.
Hey Keely, what will happen if you put a number tile under it?
The number on the number tile means how many seconds you want it to get hold.
What do those long tiles mean?
The long tiles are called melody tiles. They have already created a phrase of music for you. What song would you like to hear?
I would like to hear a song that you created.
Got it.
As you can see here, this was the drawing music code that we used. Now we'll talk about drawing.
What tiles do we need to code drawing?
We'll need the movement tiles. The movement tiles have arrows on them pointing in different directions. Those arrows mean which way the robot will be going. There are go forward, go backward, turn left 90 degrees, and turn right 90 degrees. If you don't want it to turn 90 degrees, you can put a degree tile under it. For example, this is turn left 60 degrees.
Can you show us it? Is there any more tiles?
Yes, the repeat tiles. There are two types of repeat tiles. One with the triangle, which is called the start repeat tile, and one with the square, which is called the end repeat tile. You first put down the start repeat tile, then the line of code you want to repeat. If it is only one tile, you can pick up that one tile and put a number tile under it. The number on the number tile means how many times it will repeat it. For example, this is go down 5 times. If you do not want if you want it to repeat multiple times, you can put a number tile under the start repeat tile. Lastly, you put down the end repeat tile.
Can you show us a demo?
Sure, the drawing manual has a special sequence that they organized it into. It starts from a simple shape, like a square, to more complex. A flower, a house. I challenged myself to turn this house upside down and code it. Here is the start point. Now we first are forming 3 sides of the square. Go forward, turn left 90 degrees, go forward, turn left 90 degrees, and go forward, turn left 90 degrees. Now we are forming the triangle. Turn right 60 degrees, go forward, turn left 120 degrees, because if you keep on going, it would be 180 degrees, and the spot you're on is 60 degrees. 180 minus 60 equals 120. Go forward, turn left 120 degrees again, and go forward to finish the triangle. As you can see, in our code, we repeated go forward and turn left 90 degrees 3 times to form the square. Now you're forming the triangle. Turn right 60 degrees, go forward, turn left 120 degrees, go forward, turn left 120 degrees again, and go forward to finish the triangle. Now let us see if it works. Open the cap. Open the cap of the marker. And put it in the hole. Now let us see if it works. Forming the square. Now it's forming the triangle. Forward, go forward, go forward. It worked! I learned about obtuse and acute angles. I hope you learned too.
Great, this is fun.
You may ask any questions at 8 o'clock. Thank you.
So next is the Matatalab Autonomous and Teleop Programming. So can Otto please share the slides?
Project team. Name, Jack Chen. School, the Guthrie School, grade 1. Autonomous mode. Robots can be programmed to move on their own without human control. Code instructions must be detailed and specific. They must have sensors to see the things around them. Some real-life examples of autonomous robots are the SpaceX drone kits, self-driving cars, Roombas, and package delivery robots. Teleop mode. Other robots require a human operator in control. The controls must be easy to use. They are often used in situations where an autonomous robot is too hard to use. Some real-life examples of teleoperated robots: Mars rovers, military drones, submersibles, and remote surgery robots. Trade-offs. Autonomous, complex and difficult program that must respond to any unexpected situations. Versus Teleop, simpler program but requires training to operate and subject to a human error. Many drones can operate under both modes, which offer different advantages for different situations. Matatalab. I use Matatalab coding set and sensor pack to demonstrate these two types of robotics in action. Here are the programs I used. Autonomous program. Sensor used. Distance sensor. Light blue blocks waiting for sensor. Motion used. Red blocks moving forward. Green blocks turning. Teleup control. Controller allows the user to move the robot by pressing buttons on the remote control. Clear. Live demo. I'm going to show you a live demo. Autonomous mode. The goal is to let the robot goes forward. It detects the first obstacle, which is the blue one. Then it makes a right turn and goes forward again. It detects the green obstacle and makes a left turn. Now it detects the boundary and makes a right turn. It goes forward and goes to the destination. Now I'm going to change the obstacles and run the same program again. Now the robot goes forward. Now the robot goes forward. It senses the green block, the blue block. Now it turns 90-degree right and senses the left, the orange block. Now it goes forward and senses the wall. It turns Wait. Is it the It goes forward and turns 90-degree right and goes forward and turns 90-degree left. It goes forward again and turns 90-degree right and it arrives at its destination.